Okay, hi guys. We're going to talk about carbohydrates in this video. You'll notice that there's not a video for 1.1, which is just sort of like a general introduction into biological molecules generally. So what that talks about are two terms that we've got to be familiar with in that section, are condensation reactions and hydrolysis reactions. Now all this refers to are reactions that produce water, so that's where H2O is made, and reactions that require water in order to cause a split, lysis meaning to split. So as long as we've got a grasp of those two terms, we can understand where biological molecules can be made and split. And this isn't just carbohydrates, this is anything, fats, proteins, nucleic acids, all biological molecules undergo these reactions, and this is making them up and splitting them apart. So we talk about carbohydrates in general, we're going to be talking about energy. That's the purpose of them, that's what we remember from GCSE. They are used in respiratory substrates to produce energy, and that's their main purpose. But as we'll see later in year 2, they can be used as the basis of other biological molecules. So we've got to have a firm idea about the most common monosaccharide. We'll talk about what that term means in a sec, which is glucose. So glucose is the basis of all those respiration equations and photosynthesis equations that we did at GCSE, and it's a 6-carbon molecule that has these structures. Now, the reason I've drawn 2 here is you'll notice the difference is the OH group here, or the hydroxyl group, and these 2 different isomers is different. That's the only difference. So we've got an alpha glucose molecule and a beta glucose molecule. They're the same stuff, they're made of the same atoms, they're just arranged slightly differently. We get 2 forms of it, and that's going to become important in the next video on polysaccharides. So this is a monosaccharide, it's a single sugar, mono meaning 1, and this this particular monosaccharide in glucose has 2 different versions. So you need to remember, because it will be important in bonding, this one specific difference between the alpha glucose and the beta glucose monosaccharides. So when they join together, they form disaccharides, which are where we have 2 joined together. And then when these join together in multiple chains, we get polysaccharides, and they can be different lengths. And the bonds that form between these carbohydrates we term glycosidic bonds. And that will become better explained in the polysaccharide video. So the bonds that are forming there, as we mentioned at the start here, are condensation reactions. Reactions where water is given out and that forms this molecule. So if we just have a look at an example of a condensation reaction here, which forms one of these glycosidic bonds, we're looking at 2 alpha glucose molecules here. So that's where this little alpha bit comes in prior to that. So we've got alpha glucose there and alpha glucose here, and what that kind of represents in the middle is what's left over once a condensation reaction has happened. So remember, condensation reaction is when water is produced. Now that's because originally, if I kind of remove this bit in the middle, when this bond happened, we would have had an oxygen molecule here, okay, draw it up there, big one, hydrogen molecule, and then we would have had a OH molecule here. And then on this alpha molecule, we would have had an OH here and an H here. So what happens is the 2 OHs get together and we lose 2 of the hydrogens and 1 of the oxygen, and that leaves behind just that single oxygen, giving us the oxygen that forms the glycosidic bond in the center. So this is how a disaccharide bond is formed in a condensation reaction. And vice versa, in a hydrolysis reaction where we put the water back in, all we're doing is replacing those atoms, which then reforms the bond. So if we want to split that bond, that's what takes place. It's the same process in beta glucose and when we look at polysaccharides, except remember the beta glucose on the first carbon would be pointing upwards instead of downwards. I always remember that beta is better, so it's on top. That's just always helped me remember. But if you I draw molecules out, you need to be aware of that. One other slight thing is that when we're numbering, we might refer to kind of the first carbon, fourth carbon, fifth carbon. What does that mean? The first carbon is the carbon on the front. So each of these sort of joins in the structure are representing that. So there's a 2, there's a 1. So we go around and we number each of the carbons just to give us an idea. So we'd have a carbon come off here, wouldn't we? Of where the bonds are forming. So we'd say here we've got a carbon here which is the first carbon, we've got a carbon which is the fourth carbon, so the bond there is between the first carbon on this molecule and the fourth carbon on this molecule. So this would be termed an alpha 1,4 glycosidic bond or glycosidic link between two molecules. So the three that we need to remember from the specification in terms of what they're made from and what they show. Maltose is what we see here, which is 2-glucose, so glucose times 2. Sucrose is made up of glucose and another monosaccharide, which is called fructose. And lactose is made from glucose and galactose. And they're just kind of names that we've got to remember. So, finally speaking, we need to also know about the food test for this, which is one of the required practicals, which is a test for reducing sugars called the Benedict's test. So, reducing sugar is a term we might even encounter GCSE chemistry, which refers to the idea that if something is reduced, it gains electrons. If it is oxidized, it loses electrons. So reduction is gain, oil rig. Oxidation is loss. So a reducing sugar is one that's able to donate its electron to another substance, so that substance becomes reduced. So if A here has an electron to give, and it gives it to B, B becomes reduced because it gains that electron. So this is reducing this. A is reducing B. So a reducing sugar, unless stated in the question, is always a monosaccharide. There are some disaccharides which are reducing, but that will be stated in the question and given to you, and you'd have to break that down. So unless you are told otherwise, you would assume that a monosaccharide is reducing, and a disaccharide or a polysaccharide you would assume is non-reducing. Now, the test for this is Benedict's. Now, so often when I mark exam questions and I go through answers with students forget that Benedict's requires heat. So, if we add the reagent, which initially starts off as being blue, and we add heat, that's important, eventually, if we leave the solution enough time, it will go brick red. But there are stages in between. It will first go green, then yellow, then brown, then red. So we can say that this type of test is semi-quantitative. Because what we're saying there is that we don't have an amount. If we just say it turns red, well, how much carbohydrate is that? How much monosaccharide is present? We don't know. But if we get different colours, that indicates different amounts or different concentrations of monosaccharide. So, although it's not giving us a numerical value, that does give us a way of kind of saying if there's more or less on a vague scale. And we can use a colorimeter to measure an exact quantity. That's something I go about in one of the required practical videos. So if we want to test for a non-reducing sugar, we do exactly the same test, but a non-reducing sugar is going to be a disaccharide or potentially a polysaccharide with lots of glycosidic links. So in order to test the reducing properties, what we first have to do is to split these glycosidic links. And we do that using acid. And we can use any acid really. Hydrochloric acid is the most common. And then we neutralise that. So we acidify it and we neutralise it using sodium hydrogen carbonate or another alkaline agent. So we neutralise the substance. And then we run through the exact same test. We add heat and we add Benedict's. And if it goes red, then we know that it contains monosaccharides. So it's important that you understand these are two different tests for two different substances. This test here will not test positive for Benedict's unless the bonds are broken. So if we just did Benedict's straight off, there would be no reduction of the Benedict's reagent to a different colour, and therefore we might get a false result there and think that no monosaccharides, no non-reducing sugars are present, when in actual fact they are. So that's a bit tricky. So that's the food test. Next video I'm going to go on to talk about polysaccharides and the different types in that sense.